Hello again. All right, so this activity is looking at the one with chess expertise and people's ability to correctly recall the configuration of a chessboard. Right. So what they did in this study was had experts and non-experts, so novices, look at a chessboard, and that chessboard varied. Some of the chessboards were sort of random configurations of pieces, and the other chessboards were set up like they would be in a game play. So they weren't random, but the pieces were actually in places they could actually be based on a game. Right? And then people looked at those boards, and then they were asked to recall the exact configuration of pieces on the board. And what they looked at is the number of pieces they correctly located on the board. Right? So the first thing we're going to do is label our data file, because right now it's labeled with just ones and twos. So let's start with expertise level. All right, so for expertise level, this is coded so that 1 is novice, the non-experts, and 2 are the experts. And then for piece configuration, this is coded so that 1 was equal to the game configuration, right, so not random, and then 2 is a random. And then we're going to leave pieces that they located as our dependent variable there. All right, so to run our ANOVA, we're clicking on Analysis of Variance menu and clicking on ANOVA. And then we're moving our dependent variable, which is the number of pieces they correctly located in the dependent variable box, and the two variables of piece configuration and expertise level in the fixed factors box. Okay. All right, so first thing we'll notice is that on the right-hand side here, it gives you an ANOVA summary table, but there are no effect sizes in there. To get the effect sizes, you need to click on Additional Options. And under Display, click on Estimates of Effect Size, and we're just going to get omega squared. Right. You could also get other effect sizes as well, but we're just working with omega squared here. While you're here, get descriptive statistics as well. Okay. So there are 3 effects we're testing here. We're testing for an interaction between expertise level and piece configuration. We're also testing for a main effect of piece configuration and then a main effect of expertise level. Okay. We're going to start with the interaction. Right. So to look at the interaction, let's start with looking at the descriptive plots. Okay. So I'm going to put the piece configuration on the horizontal axis and draw separate lines for the expertise levels. Right. I'm also going to put error bars on my graph, and I'm going to get confidence intervals. Okay. All right, so let's look here at our graph. Okay. So for novices, you can see that when the pieces were in a game configuration versus random, they actually did a little bit better maybe. The mean is a little bit higher with the random configuration than with the game configuration. Experts, however, did much better with the game configuration than with the random configuration. Right? So an interaction means that the effect of piece configuration depends on whether or not you're a novice or an expert. Right? So here it looks like we have different things happening for the novices and the experts. Novices really weren't influenced much by whether or not they saw a random smattering of pieces or a game configuration, whereas experts did much better seemingly when they had the game configuration. So let's look here at our p-value for the interaction. So we have an interaction here for expertise level by piece configuration with 1 in 116 degrees of freedom. And our F is 17.44 with a P of 0.0000577, right? So it's very unlikely that that interaction we're observing is just a result of sampling error, right? So what we need to do, though, is look at this more carefully rather than just looking at it a graph. And that is, we want to know for novices, is this difference between game and random, between this 8.7 and 9.57, likely or unlikely to be due to sampling error, right? How likely is it, really, that that outcome is due to sampling error? And for experts, how likely is it that this outcome, 14.03 versus 19.23, is likely to be due to sampling error? Right? So to investigate that, we're going to do simple effects analyses. So click down on the simple main effects menu. And then we're going to look at piece configuration as our simple effects factor and then expertise level as our moderator factor. Okay. All right, so when I look at this, let's start by looking at the F for novices. For novices, my F is 0.812 or 815 with a P of 0.368, which tells us that this difference for novices between the 8.7 and 9.57 is probably just sampling error. Right? You can compute the size of that effect by computing the difference between 8.7 and 9.57 and dividing that by the average of those two standard deviations there. I'm not going to do that right now, but you can compute that effect size that way. Right? All right. Now for experts, however, we're comparing 14.03 to 9.23. And here we find an F of 25.02 with a P of 0.000002. Right? So that difference for our experts is really unlikely to be due to sampling error. But note, that's not very descriptive, right? We need to explain what happened. And what we're going to explain here is that for novices, they did about equally well in the game and random configuration. Right? However, experts did much better with the game configuration with the random. Right? They look just like the novices with the random configuration, right? But the experts did much better with that game configuration. So when you describe the interaction, you want to describe both of those simple effects. You want to say that novices did approximately equally well in the game and random configuration, and that experts did much better with the game than the random configuration. But again, remember to compute this effect sizes, Ds, for novices and experts by taking the difference between the means divided by the average of the standard deviations to get the Ds. You do get an overall effect size, omega squared, for that interaction, but all it's telling us is the amount of variability accounted for in our dependent variable by that interaction. It's usually much more interesting to look at the Ds for each of those pairwise comparisons there for the simple effects. Okay, so once you've looked at the interaction, there's still main effects to look at. Okay, so we have a main effect of expertise level. Right? So to look at the main effect of expertise level, I'm going to look at the marginal means for expertise level. So under the additional options, marginal means, I can move expertise level over into the right-hand side. You can see I have a mean for novices of 9.13 and for experts of 11.63. Okay. So that main effect of expertise level, the F of 13.576 with a P of 0.0003, tells us that that mean difference is very unlikely to be due to sampling error. Okay. And here you can interpret omega squared directly. It'll give you, it's comparing just two means, so you can interpret the omega squared. Or again, you can compute the D if you want to. Right. Now we also have a main effect of piece configuration. Okay. So we look at piece configuration. Okay. So we're looking at comparing the game versus the random. Okay. We're comparing 11.37 to 9.4. Here our F is 8.4 with a P of 0.004. Again, really unlikely to be due to sampling error, which means that overall people were better with the game configuration than the random configuration. And again, you can interpret this omega squared here for the main effect directly, or you can compute a D to compute those two marginal means there. I should note that if you want to compute the D, you need to get the standard deviations, and you'd have to get the standard deviations through the descriptive menu over here. Okay, I'm not going to do that right now to save a little bit of time, but you can get the standard deviations there if you need to. All right, so note here that the interaction is what's really important and really interesting in your write-up. When you're writing about it, you're going to talk about how novices, right, did about equally well with the game and random configuration, whereas experts did much better with the game configuration than the random. And then our main effects, you'll also mention that experts overall did better than novices. That's unlikely to be due to sampling error. And that your other main effect is that overall people did better with the game configuration than the random, unlikely to be due to sampling error. But right, neither of those main effects really captures what's interesting about this study, right? What's interesting is that you get different effects for experts and novices, right? So the main effects become much less important once you have an interaction that helps explain your data. Okay, so I haven't gone through every single thing but in the activity, but this will get you started, show you how to run the analyses and how to get started on your interpretation. Okay, all right then, I'm signing off.